Okay, class. So, as I was saying before, I got cut off. So, the magnitude of V squared is equal to around about 594. So, when we take the square root of both sides, we have the square root of 594 is equal to approximately 24. So, when we do this, we basically just use the law of cosines to do this. So just make sure when you're doing those problems, if you don't understand something, you ask about it. Now, the equilibrium, sometimes it is necessary to find the vector that it counterbalances the resultant. This opposite vector is called the equilibrium. The equilibrium of vector u is the vector negative u. So take a minute and write that before we go to the next slide. So, finding the magnitude and direction of an equilibrium. It says find the magnitude of the equilibrium of the forces of 48 newtons and what? 60 newtons acting on a point A. As you can see, point A is right there. If an angle between the forces is 50 degrees, find the angle between the equilibrium and the 48 Newton force. So we're looking for alpha. Now, if we're looking for the equilibrium, we're looking what? We found the resultant would be V, which goes in that direction. So we have a negative V resultant going in the other direction. So let's look at this. So we have the magnitude of V squared is equal to 48 squared plus 60 squared minus 2 times 48 times 60 times the cosine of 130. So we have the magnitude of V squared is equal to, so it's approximately 9,606.5. So the magnitude of V is equal to roughly about 90 newtons. So if we look at that, we're still looking for what? The angle. We found the force, but we didn't find the angle. So let's look at this. So take a minute and look at this. So we have the sine of CAB is equal to, so we have the sine of CAB over 60 is equal to the sine of 130 over 98. So the sine of CAB is equal to, move it over a little bit, 60 times the sine of 30 all over 98. So we have the sine of CAB is equal to, roughly, let's put in the calculator. As you can see, this is the angle that we're actually looking for right here. 0.4690068. So we take the sine inverse of both sides, we get roughly 28 degrees. Now, remember we're looking for the alpha. So we know that alpha plus 28 would give us 180 because they're supplementary angles. So to find alpha, we have to do 180 degrees minus the 28 degrees. And that equals what? 152 degrees. So make sure if you have any questions about this problem, you ask. Always make sure you can message me through Microsoft Teams. If you message me Microsoft Teams, I can do the problem, then I can give you illustrated help with it, and then I can give it right back to you. So when you looking for the angle in between, that's what we was looking for. So finding the required force, it says find the force required to keep a 50-pound wagon from sliding down a ramp inclined at 20 degrees to the horizontal. Assume no friction. So let's look at this figure right here. As you see, we have the ramp, and we see, if you notice, we're pulling the ramp up the hill or up the ramp. So we do got, if we look at where the wheel is at, we got one going straight down. So let's look at this. We have the sine of 20 degrees is equal to what? So we got to use our old skills of what? Opposite over hypotenuse. So it'd be the magnitude of AC over what? 50. So now, to keep some of this, you got to remember that previous knowledge that I showed you. So now we're going to multiply both sides by 50, and we'll get the magnitude of AC. So take a minute, go ahead and write that. So we get the magnitude of AC is equal to 50 times sine of 20. So put that in the calculator. You get a roughly about 17. Roughly about 17 pounds. Make sure, if you have any questions, you hit me up. I want to make sure that you understand this concept. If you wonder where AC came from, you look at the bottom. Remember that AC is equal to BF. Just keep that in mind. So find the incline angle. A force of 16 pounds is required to hold a lawnmower a lawnmower on incline, what does hold a 40-pound lawnmower on incline? So we have the sine of B. We have the sine of B is equal to 16.0 over 40.0, which is equal to 0.4. So B is equal to, when you take the sine inverse of both sides, around about 23.6 degrees. So right now we're just using some of them old skills. So make sure you understand what's actually going on. So just make sure you go through this problem so you'll know exactly what you need to do. Make sure you have any questions about this, you ask me. So let's look at this. A ship leaves a port on a bearing of 28 degrees and travels 8.2 miles. And it says that the ship turns due east and travels 4.3 miles. How far is the ship from the port? What is the bearing from the port? So let's look at this. So let's look at the figure. So if we look at the bearing, remember we talked about bearings in previous sections. We talked a little bit about it. So looking at point P and how that bearing goes. So you want to make sure you are looking at the right directions. So we look at point, so that's PAE, and we see that's 118 degrees. So if we want to find like NAP or NAP, we know that we just subtract the 118 from 180. So make sure you look at the figure and make sure you're doing what you looking at the figure and you're looking at what exactly you need to find. So now we got 180 minus 118, which gives us around about 62 degrees. So we're going to use that 62 degrees because it's complementary to what? That side. So we're going to have PE, which is the magnitude of PE, squared, is equal to 8.2 squared plus 4.30 squared minus 2 times 8.20 squared, not squared, times 4.30 times the cosine of 118. So we have the magnitude of P squared is equal to, let's put it in the calculator, it's roughly about 118.84. So when we take the square root of both sides, we get around about 10.9. So we found how far it is. Now we got to find what? What is the bearing from it? So let's move over here. So we have the sine of APE is equal to over 4.30 is equal to sine of 118 degrees all over 10.9. Now we'll go multiply the other side by 4.30. So let's look at this. And make sure you understand where they're actually asking you to do this from. So we have the sine of APE is equal to 4.30 times the sine of 118 over 10.9. Now we have the sine of APE is equal to, let's put this in the calculator. It's roughly gotta make sure we put this in the calculator correctly. So we put in the calculator, we're gonna get should get 0.34831877752. So check your calculators, make sure you get that. So 0.34813 or 187752. And now we're gonna get APE is equal to, which is the angle. We'll take the sine inverse, so you should get around about 20.4 degrees. So when we're looking at this problem, we just found the angle that's APE. Now, keep in mind that we're really looking for the whole bearing angle. So when we're looking at the whole bearing angle, we got to do the bearing is equal to the original, what the original bearing was 28 degrees, plus the 20.4 degrees that we had from the beginning. So that'll give you around about 48.4 degrees. So your bearing is 48.4 degrees. So looking at airspeed and ground speed. Now, we're not going to do much of this. I'm just going to give you the definition. The airspeed of a plane is its speed relative to the air. The ground speed of a plane is the speed relative to the ground. So the ground speed of a plane is represented by the vector sum of the airspeed and the wind speed vector. So we're not going to do much with this, but I'm just giving you the definition.